So my name is Roni, and I'm here to talk about continuous feedback and open telemetry. And if you're thinking this is going to be just like an open telemetry talk where we kind of say how the technology is amazing and show you how to enable it, then you're a little bit wrong because I've frankly had enough of these talks. Not that I think that it's not useful, it's just that we've had a lot of them already. So what I am going to try to do in this talk is to take it a little bit to the next level, to speak less about the technology and more about how we can actually use it. So just as a preamble, before I start, some kind of background about me. I'm a developer. I've been a developer for over 25 years. Java was actually my first language writing professionally. Um, Although it was a very different Java back then with way more XMLs. Um, Most of kind of this talk and the tools that I'll talk about and all of the initiatives around that started because I was very frustrated, which is a great motivator, by the way, to get started on different projects and to create innovation. And I was very frustrated by many things around observability. And I hope that by the end of this presentation, you'll A, share my frustration, but also be optimistic like I am now about the way forward. So I use this term continuous feedback. I know it sounded like a bit of a strange term. I want to swear to you that I did not make it up and I will prove it as well. But let's discuss about what it actually means. So for me, continuous feedback is about two very simple questions that we need to ask ourselves. Um, the first question is, what do we actually know about our code? Now, this again might sound like a strange question, like, what do you mean, what do I know about my code? But consider for a second, what do we actually know as developers about our code, about how it influences system behavior? You can think about it like maybe a spectrum where on the one end, you can think about, do I know even basic things about my code? I'll give you an example. So a while back, maybe some 8 years ago, I had a member of my team work on this really important feature, this rewrite of the data access layer, some really big changes. And he's been working on it meticulously for about 2 months, rolled it into production. Of course, he ran all of the tests. Everything was great. And as any developer would, the minute after he finished that feature, he moved on to the next feature, of course. And it took us about maybe 3 to 4 months to discover that his code never ran. There was an if statement, it was feature flagged, it was never actually in use. So going back to this original questions about what do I know about the code, the very basic thing we should ask is, do I even know that my code is running, right? Um, and that's kind of it sounded very trivial, but if you consider it, when I went to that developer and I asked them, hey, like, why didn't you check that your code is actually running in production and people are using it, or I'm not even talking about even more important questions like, did it work? Did it make things better? Um, and he basically looked at me and he said, well, how did you want me to check that? And frankly, back then I did not have a good answer. So the first question is, what do I know about my code? And the second question is really, when do I know it? And in this case, 4 months later is a bit too late. You might say that, it's as soon as possible. Sometimes some things you could know even before they're in late CI or production. So if you think about the when question, we can think about like the different tools that we have available for us to understand things about our code. So we have debugging, and we all use that, but it's very limited, very manual, very reactive, and also not indicative of anything. Like the fact that you captured a thread in a space and time kind of isolated occurrence doesn't mean anything about how it would behave when running at scale or when running in your production systems. Tests, similarly, I hope everybody writes tests, but they're very narrow in scope and very prone to biases. So, there I think a gazillion different memes about how kind of it's all of the tests are green, but production is failing, and people were very creative in finding different metaphors for that. But it's true. Basically, your tests are a good guardrail, but they're very limited as well. So they often give you a very partial picture that is mainly around your assumptions. So continuous feedback says something different. Basically, if you look at this diagram, you see something that's very linear, right? It has a start and an end, but as we know, it's more of a cycle. And continuous feedback just says we can get feedback all of the time, and not just in that instance where we're debugging or in that instance where we're testing. And this is a bit different of an approach to how we can write code. So I'd like to give you a different example. And this is an example of a member of my team that I consider to have the potential to be really a 10x engineer. And it has nothing to do with his technical aptitude. It has to do with how we approach the problem. And to tell the story very briefly, one day I was pulling the latest changes from from the main branch, and I was running the code locally, and I was noticing there was a lot of console out statements that were very strange. Like a lot of numbers were spamming my console. So it was like 30, 40, 60, 80, 20. And it kind of looked like the Matrix, kind of all over my view. And it took me a while to track down what was happening. And eventually I saw somebody committed this, system out line to the source code. And I went and found that developer and asked them, what's up? Why did you do that? Is everything okay? Do you have is there a number problem or something like that? And he said, no, I'm actually sorry that I committed it, but here is what I was trying to do. And basically he was working on a batch job, a data processing task where it was running iterations on, batches of data. And as he was adding more code in, he was printing out each time how long each iteration took. And somehow in his peripheral vision, he was following that. And then his spider senses was kind of alert him if there were like too many high numbers, too little numbers that were in the low. And this would kind of alert him to the fact that the code that he introduced um, changed the scalability or performance of the system. And I have to say, I was stunned, and I have to say two things about that. First of all, he was the only developer in a team of over 10 people that thought to do something like that, that thought that he's responsible not just for throwing features over the fence, not just for deploying code, but also to what would release look like. And the second thing is that this is absolutely the wrong way to do it in terms of toolings. So thinking about that, I actually went back to the kind of what is the standard model today, I guess, of software development practices, which is the DevOps loop. I really hate this diagram, but it's the first one that comes up if you search for the DevOps loop on Google, so it must be true. And here's also the part where I kind of prove to you that continuous feedback is a thing because it's right there, right in the middle of the diagram. But there's something very peculiar about it. And see if you can spot it yourself. But if you study this closely, you might notice that each of these stages that are indicated in the DevOps loop has tons of tools associated with them, except for continuous feedback, which somehow only has Salesforce attached to it, which I frankly still didn't figure out, even though I did reach out to the author of this diagram to try and understand if it's a plugin I'm not aware of or something like that. But this major part, like of the DevOps loop, like if you think about it symmetrically, taking information back to the developer from operations and from kind of the way that the system behaves should be as important as continuous integration, which is kind of the equivalent symmetrical process, taking the releases into production. And yet, look at how neglected it is. It's almost like there's a big black hole in the middle of this diagram. And of course, this is one of these things that one I've noticed it was very hard for me to unsee. Um, and again, I think this is a very terrible diagram, by the way, because things are not as linear as it suggests. So you don't really need to wait to release something and then start collecting feedback. The way I think about it is feedback needs to happen all of the time. So as we design, develop, test, and operate all of the time, we can collect feedback and get really useful information. Now, this is the part in the presentation where you might want to tell me, hey, this is very nice, but it sounds very fluffy. Like, what type of feedback are you talking about? This is all very abstract. So let's try to get a little bit more practical and take a look at a few examples of what type of feedback I'm talking about. And then maybe we'll get also to the root of my personal frustration about this. So I'm just going to give a few example use cases. There are numerous different examples. And then we can look at the code and see how we can actually discern and find out that type of feedback today. So the first example is, how do we actually understand complex code for efficient design? What do I mean by that? Well, if you've been a developer for a while, then you probably share the same sentiment that often the problem of writing the right code is not the writing itself, but figuring out how everything works, where to introduce the change, what is the correct way and correct place to insert your change, and then writing the change could be very trivial sometimes. And the question is, what tools do we have to actually look at a very opaque piece of code and understand the behavior and understand how are we going to introduce the change? Now, this might look a bit strange because until now I talked about feedback that happens after the fact. For example, you roll in a feature, you want to get feedback about whether it's being used. But this shows you how cyclical it is, because if you're working on a system that's already running and already has data, then it only makes sense that even when you're designing a feature, you'd want to use feedback to understand the system better and to write better code. So let's take a look at some code and see how we can do that today. And I'll try to be very mindful of time because we have lots of ground to cover. So if I take a look here in my IDE, I opened a very familiar project called Pet Clinic, which is kind of a canonical example and one that I don't really like because it's very CRUD-like. So I added some functionality to it so that now it has another microservice. It has a vaccination microservice that has Kafka to kind of queue jobs for synchronizing the pet vaccination history. And then what I've added, and I had a long flight like a couple of weeks ago, which was a great opportunity to write code, by the way, I really recommend it. What I've added was basically the ability where we can actually take a pet, add a new pet. Let's call him, oh, sorry, not an owner. Let's add a new pet to an owner. I didn't make all of this, by the way. This is like the existing pet clinic, but my humble contribution, which I'm extremely proud of, is not this validation, is this. Basically, we have a new field called needs vaccine, which is awesome because behind the scenes, it actually looked at this fake API that I wrote. It ran asynchronous processes to get the pet vaccination information and to tell me whether my pets need a vaccine. Great. So having done that, now comes the time where I want to make a change or add a new feature to my vaccination service. Now, in here, I was using a framework called Spring Batch, which kind of makes it hard for me to troubleshoot because, as you know, Spring Batch is, well, it's a great framework, but it's kind of abstract. So if I wanted to understand exactly how this works, I would need to kind of trail down and kind of chase different threads to understand what is the flow of control here. You know, there are more than one processes using this. I have a schedule job for synchronizing it. It could come from some UI triggers. There are different flows that I need to consider. So as would happen each time, I would need to spend some time understanding how the system works. If it's code that somebody else wrote, it would take me more time. If it's code that I wrote more than a week ago, then it might as well be somebody else because I'm that forgetful. So the question is, what tools do we have to understand what is happening here? Um, so one of the nice things that we have today that we didn't have before is that it's very easy to enable observability on top of my code. Now, I'm not going to get into all of that because, frankly, we don't have the time, and there are amazing guides about that. But it's very easy to get metrics and traces in addition to logs to kind of allow me to understand the code better. Now, OpenTelemetry is a standard that is now pretty much the gold standard for collecting this type of feedback. Now, it's not a very revolutionary standard, so it's not as exciting in that sense. But at the same time, I think it's amazingly exciting because something happened with OpenTelemetry that did not happen before, and that is that everybody agrees on it. And as a result of that, all of these libraries that we're using, if it's Spring, Quarkus, Micronaut, if it is, you know, JDBC, if you're using Mongo, if you're using Kafka, or if you're using Rabbit, all of these libraries are already exposing exporters that make it very easy for us to get the observability data. And so just moving from a project that has zero open telemetry observability, whatnot data to having almost too much data is trivial. It's just adding a few environment variables. I've created a guide that I'll share with everybody later. I just want to say that in general, like this is not going to be like OTel 101. I'll share a link later, but it just in terms of time and also the need to have another OTel 101. I'm not going to go into it. I'm just going to say that it's very easy to activate the data. Now, what data can we get out of it? If you're familiar with tracing, which is what we're going to focus on first, tracing is just a way to visualize how our request kind of unfolds. So it allows me to look at a process. In this case, we have this process that I've created that has like a Spring Boot API and the Postgres and all of that that came from the pet clinic, and then Kafka, some other application listening to the Kafka, like a consumer listening to the producer, and then we have a Spring Batch job, and that works with an external API and some database access. So all of this, what happens, like an anatomy of a request, if you will, is very easy to understand just by looking at the data. So let's take a look for a second at what a request look like. All of the tools that I'm going to show today are going to be either open source or free for developers. And full disclosure, I'm also going to show a tool that I'm working on. Cool. So the first thing I'm going to show you is, as this was going on, I didn't tell you, but I actually activated OTel. I'm saying activated or enabled because it's people say I need to install it. You don't need to install it. You just enable it. You enable an agent through an environment variable, and that's it. So in this case, I'm going to, I already pulled up Jaeger, which is an open source tool for visualizing the traces. And I can take a look at what was actually happening. And here I can actually see an example of a trace. What we can see is that, first of all, it's distributed. So we have more than one microservice in this trace. and we can actually see everything that was going on here. Um, is this useful? Perhaps. Some can say that it can be useful. It does give me kind of indication of what was going on in the request, so I can see everything from the SQL statements, the individual SQL statements, the APIs, lots of these things I didn't need to work to get. I got them automatically. I can see information about the batch job. It's kind of cluttered, but it gives me an indication of what was happening that may allow me to understand better what I want to change or how or where do I want to make that change. Now, that is nice. There are several problems with this workflow. And here is where my frustration started building up because it's kind of very manual to now think about, okay, I need to find examples of how this code is being used and start looking at those, looking for kind of an understanding of how my application works. But we're going to leave that aside for now and hurry on to the next example because I think that would make it a little clearer. So in the next example, let's say I did already introduce the change, and now I want to understand, let's say I'm in that same position that the developer that I mentioned was in, and I want to understand whether I've introduced a bottleneck or a scaling issue. And the question is, and I ask that to you, the audience, like, how do you do it today? When would you identify that you introduced a bottleneck or a scaling issue? How do you kind of root cause analyze it once you do have an indication from the monitoring system that something is wrong? And here is where my frustration is almost kind of coming to a boil because all of the information about all of these issues is in the data that I just showed you. Okay, so let that sink for a second because this is an individual trace. It's one occurrence in time. If we look at the entire picture, we actually have access to many different traces. And if I analyzed all of them, I would be able to see a lot of different things. Some of them are like large scale issues, like maybe a bottleneck or something like that. Some of them could be small anti-patterns. Like just scanning through this, I can see issues. And maybe it is because I can already read the matrix or just I've been staring at these for too long. But for example, this definitely looks like an n+1 select. And I can tell it to you because I'm looking at, because I've seen a gazillion other examples and it kind of makes sense to me because I've added a relationship and I probably was not too careful about how the joins are being handled. So the frustration boils down to the fact that whereas we do have access to some raw data, there's a lot of valuable data hiding there in the observability. How do I know that? Because I've personally been witness to numerous occasions where there was a very problematic issue. And after we've analyzed the logs and, the writing was on the observability wall, so to speak, because eventually we were able to track down the problem and it was always there. It's just a matter of how do we actually surface it faster, which again goes to how do we get feedback. So let's close on these two examples for a second. Let's see an alternative approach, which is what is wrong with what we've just seen. So we were talking about continuous feedback, but what I've just showed you was OpenTelemetry, observability, and things that are very easy to collect is something else. It's manual feedback. So similar to testing, where we couldn't just rely on developers kind of out of the kindness of their hearts running tests or the suite of tests, we cannot just expect developers to use these tools all the time to be more productive, for example, to understand how the system works, or to find issues earlier. If we look at the other spectrum of, or the other side of the feedback, where we roll out changes and we want feedback as fast as possible. So how do we reconcile that? How do we find an alternative approach? And you know what? When I went back to my team and I told them, hey guys, you have to use observability. From now on, you need to look at the traces. How many times do you think they actually did that? And if you can feel free to guess an answer or to just post it in the chat, but it was actually twice. Once they looked, they found something so horrible that they needed to also fix it, and then it fell on them to kind of take responsibility for it. And that was the last time that specific developer looked for trouble in the observability. And then another time, another developer just didn't find anything. He repeated the experiment twice and then got to the solution, to the conclusion that since he didn't find anything twice, there is nothing to find. And he stopped looking. So obviously, looking at tracing manually in Jaeger or at metrics using Grafana or Prometheus, that's not the right answer. We need something more continuous. So I want to share with you briefly something that I've been working on. And again, full disclosure, this is my project, but it is also free for developers, which is why I feel very confident showing it to you because there are alternatives. They're just all commercial. So this makes it very easy to share and show. And what I'm going to show you is basically an IntelliJ plugin. And what that plugin does is essentially just do what I just mentioned. So it's looking at the same data, the same observability that's very easy to enable. In fact, it makes it extra easy to enable because once you install the plugin, you get a toggle button. I love toggle buttons. And this toggle button just allows you to turn it on and off, observability. That's it. So no need to download any agents or to read those 101 articles about how to enable OpenTelemetry. This will just enable it for you. And one thing I'm noticing right away is that it's actually tracking the recent activity or the recent things that I've done in my code. And if I look at this same kind of abstract piece of code, I can now kind of see different insights. So, for example, I can see this step or this job or these different entities, but the information is now right here in the IDE in my code. And I can take a look and actually see what's going on here. And I can see that there's actually a slowdown source detected, probably based on my recent changes. And this kind of addresses the first use case that we talked about. I can also see some analytics that would allow me to see how this is being used. So I can see that this particular job is being used in two places, actually by the schedule synchronization and also when you trigger a pet new action. And if I want to take a look at how at that trace, it's very easy to do it. Only this time I can do it from the perspective of the endpoint being called. So I can take a look at the code first and then see, okay, what do I need to know about it? And the other thing is that this is superimposed, like the observability is superimposed on my code. So I can take a look at anything here, let's say this controller, and click on code to see where that is happening. And definitely, I can continue kind of following this cookie crumbs and find a lot of issues that I did not notice. So there's a high number of queries here, and 97 queries for an endpoint is definitely a lot. I can go to the trace and see exactly what's happening there. Here is that N+1 that I was talking about that was just caught automatically much earlier than I would have found it otherwise. And in general, what we've succeeded in doing is creating a flow where all of these issues are coming to me instead of me needing to search them up in some place. And the kind of effort, and this is just effort, right? It's not rocket science. It's just effort to analyze more than one trace at a time and find these different things. It's just done automatically. And, if we can create this amazing machine learning models that can generate bad code really quickly, we can definitely use machine learning models and data science in order to analyze what our code does and give us those indications. Cool. So I'm not going to go into other examples because we're definitely short on time. I just want to say that for me, the frustration again is how do we make that data not that useless? So to know is not as important as to understand. And if we actually have a gazillion of traces, and I kind of think about it like, we have the same problem with infrastructure where sometimes it has a very bad utilization or yield where you can have tons of VMs and you're not really using them. And at the same time, I sometimes visit these companies that have amazing observability and amazing looking dashboards, but For the developer, they're just screenshots. They're not useful. So how do we, on the one hand, save the right data, and on the other hand, add this data processing to bring us the important things from that data? This is, to me, the critical part. So if you're interested in knowing more about OpenTelemetry, about Digma, which is the project that I just showed you, or about any of the other tools, I did create, or about how to do the OpenTelemetry 101 thing, I did create a QR code with a link to a continuous feedback page where you can actually access a lot of resources. Main things I want to say is no code changes are needed to start using observability. No heavy lifting. You can use only OSS and free tools. You don't need to send any data to the cloud at any point. And you can get from couch to full continuous feedback in about 30 minutes. And that's an exaggeration. So with that, thank you so much for listening. This is only my favorite topic in the world. And if you do need to reach out, if you go to this link, my contact details are also there. Thanks a lot.